Hello, everybody. Welcome to the console to mobile porting talk using Unity. Some quick introductions. My name is Alex Schwartz. I'm the chief scientist, also the founder, CEO, and most importantly, the janitor of Owlchemy Labs. We are a small independent game studio based out of Boston, Mass, and we try to create silly, polished games.
I'm the CTO. My name is Devin Reimer, also the Chief Technical Owl and resident Canadian at Owlchemy Labs.
And here's a photo of where we work in the labs. As you can see, there's Albert, our lab owl, who takes care of housekeeping.
He does all the work, actually.
Yeah. So a quick background on Owlchemy Labs. Our first game that we started off with was a game called Snuggle Truck. Some of you may remember it as Smuggle Truck, but in this one you take a bunch of stuffed animals in a rickety rusted truck and drive them over the border to get free health care. So Snuggle Truck was actually released in May 2011. It was a 6-month development cycle for the game, built in Unity. Everything that we've done since starting our company has been done in Unity. We've garnered some awards. We've been lucky to get some recognition for the game. You can see here. We followed that up with our next original game, a game called Jack Lumber. Jack Lumber is a game about a supernatural lumberjack. The premise is a tree killed your granny and you're out to get revenge on the forest. Typical lumberjack story. So you can see here we were also lucky enough to garner some critical acclaim for the game, and that went really well for us. The next game that we worked on is called for the Awesome, which was a collaboration with another local Boston studio. And so we built the semi-sequel to the game and also brought it to mobile, which you can see here. We actually have a screenshot of it running. The mobile version ended up garnering a 90 Metacritic. We're very proud of the work we did bringing it to Unity, and we'll talk a little about that in a bit.
So very recently we released Oculus, which was, we brought Oculus Rift support to and so that was like the perfect candidate for it. And it is so awesome. We have it actually outside at the Oculus booth today, so if you guys want to check it out, go over there and check it out and fall off some buildings.
Yeah, I highly encourage you to check it out. The walking off the edge of the building in VR really is a trip. So the next game we worked on was another collaboration with another Boston studio called Shoot Many Robots, and that's what we're going to be talking about today. So we're going to do a quick case study on how we went about doing this console mobile port, Shoot Many Robots. So, what is Shoot Many Robots? Shoot Many Robots is a PS3, 360, and Steam title, PC and Mac, created by Demure Studios, located in Boston. It's a 4-player co-op run-and-gun RPG, right? And it actually kind of plays a lot like, let's see, Castle Crashers or a Metal Slug or something like that. So hot seat multiplayer. We're going to show you a quick video of the gameplay. So this continues on, but I'll stop it there. I think you get the general concept. You shoot a bunch of robots, right? So with Shoot Many Robots, we decided that, so we heard Demure was trying to port the game directly to mobile. And their post-mortem of doing this actual port concluded that A, the control scheme was way, way too much for doing a mobile game. Also, the real-time synchronous multiplayer aspect of the game didn't quite work out, wasn't really feasible to do as like a LAN iPhone, Android game, and it's not really the standard for how people seem to be playing with their mobile devices today. And also their custom engine written in C++, porting it to iOS and Android would have been a ton of work, which, yeah, that was going to be a problem. So we talked to them about this, and we ended up pitching them. And the pitch was, we can do this mobile port. We can build it, and it will be fun, and we'll do it in 6 months with our core team of 5 at Owlchemy. And what we plan on doing is using take their IP. We're going to take the core essence of what Shoot Mini Robots is, and we're going to bring that to mobile, not necessarily the exact replica of the game. But what we needed from them was creative license to be able to kind of take their IP and mold it into what we felt was going to be a good experience on mobile. And we also needed trust from them, because we're going to take their baby, their in-house project that they spent years on, and we were going to take all of that and try to make something else out of it. And we would do it in Unity. And this was not the first time we had pitched another company on attempting to do something like this before. As I mentioned, was also a game that was a similar type of established game to mobile port. So, as I mentioned, is it was an IGF winning game, or IGF nominated game in 2009 for gameplay. It's a PC only title at the time of us approaching them. And so we said, we're going to create the Mac version first off, but we're also going to turn it into a semi-sequel. We're going to rebuild the entire game. It was using 3D Game Studio, if anyone here is familiar. So basically they had a C-like scripting language, and it was a proprietary engine, only exported to a single platform. And so we ended up doing this port to Unity, so we brought it all over into a new engine. Now, but there's a big difference between what we did with and this new project that we were trying to pitch. We're going to bring this console game to mobile, right? Shoot Mini Robots is a much, much bigger game. We have fully rigged high poly characters, and all the characters have attached skinned gear and weapon upgrades and attachment bones and stuff like that. We had fully rigged high poly robot enemies, and there's a ton of them, as you can see, on screen at the same time. A lot of on-screen models, so really high poly count. We have complex environments. We have effects going on, a lot of layering, a lot of overdraw, and this, it's meant for a console. And there are some problems with, bringing this to a mobile platform.
All right, so we had to make a design assessment. So before we dove into actually the tech, we decided, what is this game? What makes Shoot Mini Robots Shoot Mini Robots? We needed to identify that and determine what we could carry over into the actual game. So these were the core features that we listed out. So it had dual stick controls, synchronous multiplayer, shooting tons and tons and tons of robots, 8-way directional movement, free aim, lots of robot jokes, and tons of weapon upgrades. So some of these would move over easy, but some would not. So this is kind of what we boiled it down to. We wanted to be shooting tons of robots, upgrading and buying lots of weapons, and lots of robot jokes.
Right.
As you can see, we kind of really slimmed it down, so we needed to rethink the gameplay quite a bit.
Well, without those 3 elements, it wouldn't have been Shoot Mini Robots.
Okay, so this is a screenshot of the console version of the game, and we wanted to compare to the final product on mobile. And so this is what we got it to look like on mobile. So I think it's pretty impressive what we were capable of doing on mobile compared to the console version.
Yeah, that's a screenshot from the iPhone 5 version. And so you can compare it, again, to the console version. It's pretty close.
So here's a quick gameplay demo of the mobile version. And you see here we're currently in the RV, which is kind of your store for purchasing and upgrading weapons.
So as you can see, we turned the game from kind of a unidirectional run and gun, or gunner, to a run and gun RPG. with multi-lane setup. So you can see we're changing lanes, we're picking up nuts that the robots are dropping. You're shooting a ton of robots. You're picking up weapons that exist in these weapon crates. And you can see here, oh, you hit a robot and died, right? And that brings you back to the RV, so that you get your stat screen here, and you're back to being able to upgrade your weapons. And here's kind of a later part of the gameplay. So you can see we have a dynamic lighting and day-night cycle system in the game. So as we get killing more and more robots and being able to run longer and longer, the levels are getting harder. The sun is kind of starting to come down. Notice the length of the shadow of the main character as it gets stretched longer and longer. And now we hit level 10 and we've gone into this kind of zone 2, this night world where we have a different difficulty set, we have different enemies coming at you, different levels that are being randomly chosen as you move forward. So that was the gameplay that we came up with on mobile. So what is SMR Mobile? This is the reimagining this is what we built. It's a 3-lane running gun infinite runner, and we ended up with an easy-to-use control scheme with a randomized level system that increases in difficulty as you go. And we didn't just crap out this game. There were a lot of technical hurdles that we hit on our way, and I think that's what everybody here wants to hear about. What did we learn while building this? Here you go. Let's go through the list.
All right, so the first and most obvious one was gameplay. A console game plays much different to the way a mobile game plays. So in the original game, it was a 2D side-scrolling game, so the art was built with that in mind. Players would move from left to right, and the control scheme for a mobile device would be hugely complicated. We needed a game also that had infinite replayability, so we couldn't just make a level and have somebody play the level. So we decided to go and make a prototype. So the first idea was we were going to make this 3-level system where you'd run across from left to right and shoot robots and aim. You can laugh. It was pretty terrible. But the good thing about Unity is we could prototype this quickly and then realize very soon that this was not going to work. The gameplay wasn't fun. The art didn't lend itself to this 3-tier system where you'd need I wanted another tier in the middle all the time. It was terrible.
Yeah, and this is one of those common pitfalls where when you feel like, as a designer, you write a bunch of stuff on paper and you're like, this is going to be great. It's going to be 3 lanes or 3 levels, and you'll have these robots which have exposed underbellies. So you got to go underneath and you got to shoot them up from above, and then you slide kick some robots. And when we talk about the game and think about what it's going to look like when we build it, we're like, yeah, it's going to be great. And then we played that and we're like, this is a pile of shit.
Yeah. So yeah, as we're saying, the aiming sucked. It's even hard to tell in there. Trying to aim at the robot, say you're on a bottom tier and you're trying to aim up to the top tier, it was just so terrible. The precision just wasn't there. The level design was a nightmare. We struggled with that a lot, even in the prototype, to get it to not be lame. The players wanted to end up staying in the middle tier because that was the easiest way to go up and down, and then we couldn't get them out of that middle tier. So it was like, okay, what kind of mechanics do we have to introduce to make them change lanes? And we were kind of patching things. So we're like, okay, we need this mechanic to fix the pass mechanic, and then we need another fix to fix that. And we kind of went down, and then we finally realized maybe it's the original mechanics that are broken.
Yep.
So yeah, rejected.
Not by the publisher / contract owner, by ourselves, self-rejected.
That's not cool. So the solution to this problem was to flip that on its side and go for a 3-lane design. As you can see here, currently is in the middle lane, and then the far lane, and then the close lane is here. And so what it allows you to do is move back and forth, and we can put obstacles in the way, which gives you a reason to change lanes lots. It fixes the aiming problem because you just shoot straight ahead in the lane that you're in, and so you want to change lanes to shoot robots. So it fixed all the problems, and then the art was very conducive to this kind of art style layout.
There were not many 3-level buildings in their art set that we could use, so this works a lot better. So the next thing, obviously, we come up with this lane system. We need to build a good input scheme to handle playing this game. So big considerations are we need to reduce the amount of time that your fingers remain on screen, especially on the right side of the screen. You're running left to right. All the objects that are going to be flying at you that can potentially kill you, if your finger is over that area, it's going to be really frustrating if you miss out on something that you should have seen earlier. We don't want to block the view.
Unfortunately, we don't yet have transparent thumbs, so.
Yes, yeah, that's a problem. And also virtual joysticks, those everybody hates those. So we needed to avoid those as well. The solution really was to just keep it as simple as possible. We came up with a gesture-driven input system that I'll explain here. So on the left side of the screen, using your left thumb, you can swipe up and swipe down to change lanes. Makes sense. We also overloaded the left side with a tap to jump mechanic. And so what happens is when you're trying to determine in code whether you've done the tap or you've done the swipe, it's about whether you've left that distance radius for having started a gesture, or whether you're releasing within the time frame and the distance that you're setting to register as a jump. Yeah. And we need that to be really quick.
Yeah,
right?
and this worked really good because generally when you needed to jump in the game, it was something I needed to do really quick and I needed to do now. So just that quick tap and release worked perfectly.
Yeah. And we also, you can see here's the actual hit area that we used in the game. We wanted to reduce the amount of necessary precision needed for the left thumb. So when you're playing a game really fast and you're getting into those like harder elements, your thumb definitely drifts from where you thought it was. So in the beginning of the game, in the tutorial, we show a thumb and it says press here, but really it's press anywhere on the left. Yeah. So. And
I think a good thing to point out was in that original prototype, there was this blue circle with a bar. The original idea, even in this, was that you'd slide your thumb up and down. It would give you good precision. But that turned out that if you were in the middle, your thumb would be right on top of your player, and that's a big no-no. Don't cover up your player. So this gesture-driven would get your fingers out of the way really quickly.
Sure. Less time on screen is better. On the right side, we had the little icons for which weapon you're shooting. So it looks like there's two separate hit areas, but the actual hit area looks like this. So this screenshot's showing the most complicated setup that could possibly be. So when you normally have an unlimited pistol ammo, and the whole right side of the screen is just shooting your pistols, so just tap, do whatever you want. Every once in a while, you'll pick up a weapon crate that has these limited ammo, limited time power weapons, and that'll place, like here's the shotgun icon right there, and that's just at a higher UI depth level. So as long as you hit within that area, you'll get the shotgun. Anywhere else, you'll get the pistol to fall back to.
Yeah, so this works if people are like frantically playing, your thumbs will drift, just natural. So you gotta make that hit area as big as possible. In this case, we just had the whole side. So that way, if you're a little bit high, it still shoots and you don't die.
Yep. And I mean, we were trying to avoid specific hit areas, but in this case, it's more like a power-up, where a power-up comes on screen, you're like, oh, I want to tap that. And so it's very targeted. And we tried, double tap for guns, but that just doesn't work because you want semi-auto, and there's no other way to overload.
And you want something fast.
Yeah. So the next technical hurdle is about the actual porting. So we had a ton of assets delivered to us. So this is kind of doom and gloom here, right? When we started the project, they sent us a 50 gig external hard drive that is, here you go for it. And so the first week, we pretty much looked through the source assets. So what it consisted of was a ton of massive 100 megabyte PSDs, these high poly rigged 3D characters and robots, which maybe 20% of the things in the asset folder were reused in the final game, but which 20% was God only knows. Yeah. So they had older versions of assets. The game's been in development for years and years, so they've built a lot of content that never actually went into the final game, but yet we had to sort through some of that older content. And that's kind of one of the technical debt issues of inheriting someone else's game and then having to port it, is you weren't there for all the discussions that went in, and you don't know what all these naming conventions mean. Final _1 last, So we have hundreds and hundreds of lines of hundreds of unoptimized character and robot animations. Again, we don't know which ones are used in game. That's fun. We have a ton of engine code written in C++, and all the game logic is written in a separate scripting language. We have these custom data storage formats, so like an INI property list that's defining, the fire rate of the shotgun or whatever in the game, and they had custom parsers to read all that data, and we were just looking at flat files, right? And then all the particle systems, all the visual effects were in a proprietary effect format that we did not have a license to even inspect. So,
and the knowledge to understand.
Yeah, so just forget about that. So the real question here, and kind of the lesson of the talk, or what we're saying is our method of porting, is, how the hell do you port this, right? The answer is you don't port that. At least you'd be crazy to. You clone it, right? What we did is we did a feel-for-feel clone of what made Shoot Many Robots, Shoot Many Robots. So we used a ton of reference material, gameplay footage, YouTube playthroughs. We had copies of the PC game and the console game running on monitors right next to our development. We would refer to these all throughout development, and we were working in Unity. We brought in 0 lines of their actual code base, nothing. Even though we had access to the entire source, all we used were their art assets, and that's the key of kind of what we're going through here. And so we'll talk about the technical hurdles of inheriting 50 gigs of assets. You got the hard drive, you have all the source assets, and so you get to the point in your design or implementation where you say, okay, we need a robot. We need that robot.
And then you drag the 50 gigs into Unity.
Yeah.
And then you delete that project.
And then you wait for the progress bar. Yeah. So, I mean, you say, okay, we played the game. We need the game that has the robot that has the like machine gun front on it. So we find it, it's the suppressor. We have an FBX file, we found it, that's good. So the problem is you don't want to import everything, like you said, into the Unity project at the beginning. First off, it would slow your development to a halt. And that's the best part about starting a new Unity project is it's all clean and everything. You hit play and it's instantly in play mode and you don't have, all this technical debt.
Yeah, an employee wants to grab it and then the asset server is just like there instead of a week and a half downloading.
So how do we get away with slowly building this game without the problems of, so basically I'll say, if you bring in an asset, so bring in an FBX, we would take the reference texture that's part of this robot. It needs this rust texture and it needs this metal and all that. And from 3ds Max 2008 that we had to use because of their old format, you're able to take all the referenced textures and bring them right into Unity. But the thing is, you bring in Robot 2, and that also has rusted metal. And you bring in Robot 3, and that also has rusted metal. And now you have rusted metal 001, 002, 003, and you have 10 copies of the same texture that are in your asset folder, and you need to deal with how do you deal with that? So our solution here to keep things lean was in our pipeline of exporting from 3ds Max to FBX, we used FBM folders, which is gathering the textures and putting them in a little folder. By the way, who uses that anymore? These guys. And we wrote an asset post-processor, and here's what it does. When you bring in the new FBX, it says, oh, you got a new texture. That's cool. Let's check if the project contains, rust, whatever. It says, oh, we found the texture here by name. That means it already exists. Let's traverse up, find the material that it was linked into, take the FBX and use that material as its material. So it does that procedure every time you bring in an asset. If it's a new texture, great. It generates its own material and you're all set. If it already was there, it uses the pre-existing material and you don't end up with duplicate files. And I think it took us, 2 months of not doing that before we said, man, we really got to write this asset post-processor.
Like, you need to write tools if things are slowing you down. Unfortunately, sometimes it's hard to see what is going to slow you down until it already slowed you down. But yeah, write tools.
Yeah. Okay, cool. Our assets are coming in. We're building this game. The problem is we're using console assets on a phone, right? So we had these 3 targeted buckets of devices, and then Android is a whole nother mess. But so you have the high-end devices, the mid-tier, and then you have low-end. And they wanted us to support iPad 1 and 3GS because it is, by definition, kind of like a very accessible game. It's an infinite runner. A lot of people play it on the App Store. They want to support some of the older devices. So we were hitting lows of 10 or 15 frames a second before we did any optimization.
Yeah, so like starting this project, this was my #1 concern, is we knew we wanted to reuse the assets to get it done in the time frame that we had, but it was like, oh, this is going on 3GS and iPad 1, console quality graphics, models and stuff like that, just not going to run well. So,
by the way, at the end, here's a little sneak peek. At the end of the optimization round, we ended up hitting that 2830 goal we were going for on low end, which is good enough. Because when you're at 15 frames a second in an infinite runner, it's so bad that you're scrolling the screen, everything's moving, and you hit jump and because the update loop's so slow, you miss the jump and then you hit a wall and you die.
And then you throw your phone on the floor. And
yeah, you don't want that. That's a rage quit moment. So we got up to 30 on low end, which was good enough. And then the mid-tier devices play it very well, and it runs like a dream on iPhone 5 and iPad 4. So how do we do that? So here's some of the little cheap tricks that we used to get better performance. So we do platform-dependent asset spawning. So in Multi-Platform Toolkit, which is a tool for determining what platforms you're running on. We bucket our devices into this, is it a low-end device, is it a high-end device? And we check, if it's a low-end device, we'll duplicate the prefab for, let's say, this particle effect, and we'll just make the low version and the high version. It takes 10 seconds, just half the particle per second count, and be done with it, right?
Yeah, and like it doesn't look too bad. Like the low-end one doesn't look too bad, but the savings are huge.
Yeah. Same with the animations for the robots. So every robot had a underscore low or underscore lower version of it in the resources folder.
So yeah, you could go through the project and then say, okay, this is my normal one, and then, oh, there's the underscore lower. This is clearly the one that has been reduced to run better on lower devices.
Right, so the reductions, again, they're really simple, really straightforward. So we would do a shader swap. Maybe it has a specular, metal texture on it. Just go mobile diffuse, right, on 3GS. So 3GS is pretty much, and iPad 1 are displaying mobile diffuse and alpha self-illum, and that's it. That's pretty much the entire game. And again, the animation sets, we had all those unoptimized animations. You have the nice optimize animation button in Unity, so all those get brought in and you just clear out some of the empty keys that weren't being used. And you end up with the cheap robot and the high-end robot. It works perfectly. We also aggressively removed assets that did not need to be there on low-end platforms. So if you don't absolutely need it, it's gone. So anything that was heavy transparency, like those grass elements, high poly elements that were in the background, and anything purely decoration, gone on low-end platforms. And the best part about that, well, I'll show you a little image here. Here's extras on, extras off, right? So I'll switch back and forth between them. We're not doing anything that affects gameplay. None of this will affect any of the gameplay. All the collision stays the same. It's just going to look slightly different. And you don't need those windows on the building per se.
Yeah, so you want to go back there for a second?
Yeah.
And so like this allowed us to get our level designer to actually help us do optimizations. So we could say, okay, go and attach these script to a transform that you don't want these things on the lower end devices. Yeah. And that takes that optimization off of our plate. And also, like, a trap that I see people fall into is, like, my game doesn't run well on the low-end devices, and they optimize down for that, so you're bringing your high-end devices down. And it's like, there's no reason for that. Keep your high devices high, and then bring your low devices down so they run well.
Yeah. I mean, when we say, oh, we're removing assets based on the platform, and we have our designer doing some custom implementation, it's literally a class called delete this on low-end platforms.cs, and it's 4 lines of code, and he just places it on the transform that says delete me on low-end platforms, and he just drags in a couple doors and grass pieces into that transform and hits save, and it just happens automatically on the low-end platforms.
Yeah, and so we were able to tell him what parts of the game were running slow, and then he could go in and then go, okay, maybe if I make this cover this area, I can get rid of all the assets behind it on low-end devices.
And a couple additional things with the performance. We had some platform-dependent code changes, really just effects. We would disable our dynamic shadows that we had running on high-end devices, on everything but high-end devices. Which is actually kind of funny. People ask us, oh, the shadows in this game look amazing, and they're dynamic, and you're doing this day and night cycle, and it's so good. Like, how did you get dynamic shadows to run on iPhone 5 with great,
all these models, and then you've got all these complicated shadows and stuff like that happening?
We just turned it on, honestly. Unity's built-in directional light shadows, brilliant.
Yeah, we had a discussion beforehand. We're like, do you think we could support shadows? And then we're like, why don't we just turn it on? And then we turned it on, and then it ran beautifully. Yep.
Just set your fade distance to the absolute lowest, and you're good to go. And of course, we're optimizing our 2D GUI and all that using our tried and true 2D solution, which is 2D Toolkit. We've been using that on prior projects, and so. This helps with the overdraw issues that you have on our GPU-bound devices. So the iPad 1, for example, it's 1024/768, and you have fill rate issues with it. So any transparency that gets re-rendered, any per pixel operation, it kills the GPU on the iPad. And then same with the iPad 3, which is funny. The iPad 2 is faster than the 3 when it comes to GPU, because it's not technically faster in cycles, but you haven't increased the pixel count yet, you got more GPU power. On the iPad 3, they quadrupled the pixels, and they only quadrupled the GPU, and it didn't get anywhere. So you end up with performance issues on 1 and 3 that involve transparencies, and you need to think about making sure your UI has the least coverage possible. It's all reduced to one draw call and all that, and You just got to be careful
It
about.
set up some interesting things though, because we considered iPad 1 a low device and iPad 3 generally a high device, but in the case of overdrive and GPU bound stuff, iPad 3 actually in some cases was a low-end device.
Yep.
So technical hurdle was random level generation. So we knew we wanted an infinite runner, and we needed difficulty to ramp up over time. We didn't want it to get boring and repetitive, but we wanted the levels very crafted, very well crafted to fit within the Shoot Many Robots universe. So what we did was we got hand-built levels, and we stitched them together. So here you can see that we got, there's 3 different level chunks, that's what we called them, and then they get stitched together. So what we needed to do was make some sort of system that would allow our level designer to quickly build these level chunks and be able to iterate on them quickly. So be able to just go hit play and be able to test what that was. Yeah. And so how we ended up doing that was we leveraged the Unity editor to build a level editor. So like this chunk, for example, is just a scene in Unity. So we had tons of these scenes. And so the, you could probably advance to the next slide here so I can show this.
Yep.
And so here's a quick video of how that works. So open up a scene, and we got this level chunk in here. And then we go here and grab a prefab, and we drag it in. And we're going to drag in a couple more here.
Yeah.
And a rock. And then what that will do is that'll set things up so when you hit play, it goes and you can, then I've got a rock in my way and I have to get around that rock. So there's this quick iteration. It's like, okay, that rock needs to be slightly bigger, and we hit play. And that allows our level designer to do things so much quicker and turn out so many more levels.
Right. That's how Unity normally works, but we're doing some extra magic.
So we didn't actually want to load all those scenes because like memory and speed. So we built a custom. You want to go back to the one before this?
Sure.
An XML system. So whenever you save a scene of a particular file name, there was a post-process that would go and convert that to a custom XML format, and then we would parse that XML format, and then we would use that to grab the appropriate prefabs out of the resource folder to bring them into the game. And so there was 2 methods of testing. You could either just hit play and run with the assets in the editor, which was really fast for iteration. But if you wanted to test the XML format to make sure there wasn't problems, there was another checkbox, like test as XML. So when you hit play, it actually saved that to XML and then brought it in, which was a little bit slower, but allowed you to get those edge case bugs.
Well, plus the platform specific.
And yes, and then the other thing is we had a drop down, and you wanted to say, what does this look like on low-end platforms? You just grab that drop down and go, okay, this is what it looks like on low, this is what it looks like on high.
Yep. And one other feature we don't write on the slides is that we were also afraid that even though we made 60 chunks and that we were going to be like putting them in different orders and all that, that we still would see the same like, oh yeah, it's the red building next to the green tree again. Like as a player, you're going to notice all the repeating elements. So we, even in every chunk, we built 3 sub-randomization zones. So we would do, what did we call them? It was like something A, B, or C, style A,
yeah.
or whatever. And so the designer would then just make minor adjustments to little things that were highly visible. So like that building there, he would do some adjustments or change the tree to a different type of tree. And so you'd have section A or B or C, not all 3 and not 2 or 3.
Yeah, and they each could have their own colliders or whatever, so that you could actually like remove that building and have a path that would run through it. So it would look completely like a new level, but it would allow our level designers to get so many more uses out of the level. So say we had 60, 70, and then we had 3 variants of each one, that all of a sudden becomes a lot of chunks.
Yeah.
Okay, so the next one was over memory. So my number 1 worry was frame rate. My number 2 worry was memory. Because now we're going to bring all these console assets over and try to get them to run on a 3GS and iPad 1. All right, so the solution to this was to pool everything very aggressively. So we pool all the particles. We would only instantiate things when you first got into the game and never again. We would very, very aggressively pool the random chunks in the levels. I will get into that in further detail. Because that was a sub-problem. How do you go about pooling random level elements? Okay, so each chunk is randomly ordered. It doesn't always play out the same way. So say you're playing really good, the difficulty will ramp up faster if you're not. So what we needed to do was we couldn't figure out what was going to come next. So what do? We pool just enough prefabs because runtime instantiation just wasn't an option. We can't have frame rate dropping at all. So the way we dealt with this was we braced for the worst case scenario. So what we do is in a level chunk, say there's a rock, and the rock is used 4 times, and that is the most amount of occurrences within a chunk. What we do is, okay, how many chunks, level chunks are going to be created? So in this, it was 2. So what would be was the level you're running on and the next one. And as soon as you left the previous one, it would then move it into the pool and then recreate the next one from that pool. That means that our maximum number of chunks was 2, meaning that if the most amount of a single item in a chunk was 4, we'd need to pool 8. And so we did that at the start and then never have to instantiate anything. All right, so loading is another huge technical hurdle. It's a pretty big one in games. When it comes to an infinite runner where you want people to fail and then get right back in it, it's a huge problem because you don't want somebody being like, oh, a loading screen, and then they set down their device. You want them to keep getting in there and play lots. So how we solved that is we adopted the motto, you only load once. So what happens is at the very start of the game, when you boot it up, it does an additive scene load for the RV, like that store. And then as soon as you go into the game, so that's a quick load. And then when you go into the game, it loads an additive scene for the actual level itself and does all the instantiations for all the level chunks. And then it keeps that in memory. It never takes it out of memory. So when you die and you go back to the RV, it's already there. So what this allowed us to do was have no level loads past the very first one. So you could just keep going back, and it was really fast. It did pose some challenges because we needed to make sure that all the gameplay, menus, everything fit into memory at the same time. Because there wasn't a time it's like, oh, we're going to lose this 100 megs when we grab this one. Everything needed to fit into memory. But this has an added advantage. Because we don't have to do instantiations and scene loads, there's no risk of a memory leak because of that, meaning that if someone's going to play the game for 2 hours straight, I don't have to worry about all of a sudden that memory ticking up a little bit and then their device crashing.
Yep. And plus, I mean, when you die in the game and you're frustrated, you just want to retry as fast as possible, like you mentioned.
Yeah, the Super Meat Boy thing that's why that game was successful. It's like the moment you died, you're back in, and then that's very important.
Yeah.
So another technical hurdle was menus and UI. So having done quite a few games, we started to realize that menus and UI eat up a shocking amount of time. This is something that's easy to underappreciate because you're thinking about, oh, the gameplay. That's where most of my effort's going to go. But menus and UI eat up a lot of time.
Yeah.
So our solution was we used Unity GUI. Just kidding. That would have been stupid. We had some options. So we've been using 2D Toolkit forever, and in a previous project, we wanted to have kind of a complex UI system for a store. So we gave NGUI a try. So what made 2D Toolkit awesome was it was great for sprites, bad for UI elements because it didn't have anything. It had a button class, and the button class was terrible. But NGUI, it also had problems for us. It didn't work well with our workflow, and it had performance issues. Because in NGUI, once you get kind of complicated, every item has an update loop that's running all the time. So even if you have a menu sitting there doing nothing, it is running and eating up your CPU, and sometimes huge amounts of your CPU. And also with NGUI, it's one of those things that we found is that getting going is really quick, but once you need something kind of complex, all of a sudden that complexity skyrockets. So what are we going to do to solve this problem? The solution was building a custom UI framework to work with 2D Toolkit. So 2D Toolkit had all these things awesome for us. It was just missing this UI framework. So over a couple projects, I worked on this UI framework and got it done for this project. The goals were I wanted something that if it was sitting there, it wasn't using any CPU. So it's an event-driven system with one update loop. It's got things like scrolling lists, checkboxes, all that fun stuff. It was great. It dramatically improved our productivity. And I actually ended up talking to the guy that created 2D Toolkit, and we worked out an agreement, and now it is free in 2D Toolkit for users of that. And I know of a lot of people that have switched over to that just because it's fast, lightweight, and easily extensible.
Yep. So our general philosophy at Owlchemy is to try to reinvent the wheel the least amount possible and only do it when absolutely necessary. So Asset Store, of course, we have to thank some of the people that helped put plugins. So 2D Toolkit, as you mentioned, Mike, I don't know if you're in the audience, but we used everything you've ever made. Prime 31, everything. So multi-platform toolkit we used in that project. GoKit.
Yeah. If you haven't used GoKit, GoKit is a tweening framework. It is so fast and allows you to do super complicated things. I highly, highly recommend that you try it out.
So we used iTween before we switched to GoKit, and it's night and day. And Bob Berkebile is a good friend of mine, but sorry guys, you got to use GoKit. And also our client wanted to get quick updates for test flight, and that was a pain point for us. We didn't want to always have to go through the entire process of building a test flight for them just to test it and all this. So we ended up just throwing $50 into Autopilot, which is a one button, it does test flight automated uploads for you, which was pretty useful for us.
The amount of time savings is crazy.
Yep. And then the cartoon effects pack we used for a couple little effects in the game, and it actually, they included a particle pooling system that was super useful and that we ended up using in the final game. So that was great.
Because as you mentioned before, we couldn't use the particle system that previously existed, so we needed to go and find some things that we could plug in. But we ended up just grabbing some of these particle systems and then using the actual images that were in the project for the particles before and just dragging them in.
Yeah. Yep. Ian's Fire Pack. So. Yeah.
Oh yes.
That was the. We only had 6 months to build the game, and we had the textures for fire, but we didn't have their actual particle, information and emitter settings. So we took some fire that already existed, put some different sprites on it, and that saved us a lot of time. And for $10 or whatever it was, it's definitely worth the couple hours we would have had sitting there tweaking a fire effect when we had better things to do.
Yeah, I think the overall thing is before you go and build something, just check the Access Store. It's really quick to do. Just go see if something exists there, because a lot of stuff is so well priced that it's like way cheaper than anything you could ever build yourself.
Yeah. So. Just remember, always adapt to the platform, know when to clone, create tools for designer-driven optimization, pool everything, and keep only what you need. So that's it. Ask questions if you want. Thank you. So any questions to the mic?
Mic in the middle there.
Hello. So if I understood you correctly, you said delete on low end. Does that mean that on low-end devices you load up the whole high-end stuff and then you delete the low-end stuff?
That's a really good question. So what happened is because of the XML format, so in the scene itself, the level chunk scene, you would attach the script and it said delete on load. And so what this would do is when I generated the XML, it would put an attribute in there. It said only put in on high-end devices. Mm-hmm. And so you would never, because it would be bad to load it all into memory and then try to blow it all away. So it never actually ever gets brought into memory on low-end devices.
Okay,
yep.
Thanks.
Yeah, that's the really only the way to pare down specific assets in the game, because if it's in the scene, it's going to get loaded on the first frame. And then you could delete it from there, but you've already done the heavy lifting, right?
Yeah. So
you're either pre-processing your scenes before a build, if it's like a platform-specific thing, or you're doing text-based
from resources.
Resources, yeah. Cool. Any other questions? Yeah.
I'll just iterate on that last question. What if it's like you're not actually procedurally generating anything? Like you have a scene, it's huge, it's full of like a massive thing of artist work, but you want to be able to scale to low-end devices without loading it first and then deleting all the stuff. Is there any ideas on better ways to do that?
I think you would need
2D
to.
2D Toolkit Atlas thing for 2D
Yeah,
games.
yeah, that's good. Like atlases, there is low and high-end atlases in some things, and that can get you a long way. One of the things, I think if it was a really complicated scene, you might have to write a tool that you could go flag things, and then when you built the scenes out, Like you would process them and then create a scene with an underscore low or something like that. And then you would load only that scene in on low-end devices. That might be one way to go.
If the platform you're targeting is a completely separate build, like, oh, I want this low stuff on iPhone, but then I want the high stuff on Mac and PC, you can use the multi-platform toolkit has that built in where you can have like, let's strip all these assets that have been tagged as delete on this platform. And then when it builds it, it duplicates the scene, goes through, it says, oh, iOS stuff, kill all that. Or PC stuff, kill all that, and then let's deploy the build, and then it reverts all that for you. So it's just you need a custom build process to handle all the little flagged elements that he was talking about.
Yeah. Cheers.
Yep. Or you could duplicate your two scenes, call one low and high, and then when you load level to get into it, you could divert to your low-end version of the game and the high-end version of the game. But that's no fun if you need to actually maintain it.
I was wondering, how did you make your low-level polycount mesh? Did you use any tool, or you were like simply grabbing it and just lowering?
So we actually did pretty much no poly reduction in the game. When we talked about like the example of, oh, you have a high poly thing, let's get rid of it on like low-end devices. We would take like there were these big cranes in the background of the game. And sometimes you actually ran on the cranes in some of the levels, so we needed to keep it together, but we needed to build like a lower end version. So we'd pop it into Max or Maya and create an element or a sub-element of it. And so all these like really intense scaffolding things, and we'd take out 20,000 polys in a crane, which when you think about it, trying to render 20,000 polys on a little background element in a mobile game is just absurd. So we just found the most absurd things we could find in the game that were like really poorly designed art files and just would strip them out on low-end platforms. We were just talking to someone about like poly reduction, poly crunching tools. There's a couple that people are offering now, and one that's in Unity, one that you send your assets away, and then 3ds Max has their poly reduction algorithm, which is, I think, better than Maya's. And so you could just throw your FBX in, turn it to 50%, and then export it again. If you don't get too close on the camera, you might not see some of the imperfections that it caused. Your artist will be crying, but it might help you in the end when it's so small that you can't tell the difference.
Did you utilize static or dynamic batching at all for your 3D rendering optimizations?
We actually disabled dynamic batching in the end, right?
Yeah. I admit I made an error. It was one of those things that was a good idea at the start of the project. So when I built my XML system, I built it to support scale. So I was like, oh, you might want to scale things up, right? And then so gave it to the artist, and the artist went and did lots of level design stuff and scaled things around. And then I went, oops. And then so I went out and looked back, and I was like, okay, we can't undo this. Like, the scale has now become very important to the system. So we ended up turning it off because it ended up eating up a lot of cycles to try to figure out dynamic batching, and that wasn't actually going to help us out.
Plus, the camera angle was not very conducive to dynamic batching. So really, the only savings you got was, oh, look, two trees happen to be on screen at the same time. Let's turn them into one mesh. But the processing time it took to figure out that you should take these two trees and combine them was way, way worse than the actual savings.
And no use of static at all?
Well, because the scenes were loaded via XML, right? We can't do a static batching.
Okay, thanks.
Yeah. If we were pre-authoring those levels, everything would have been static except the character, and that's about it. But yeah, procedural level generation, you can't get away with the static stuff. That's why we couldn't also bake lighting into the levels either. And we had to go with dynamic because there's no way to pre-process your lighting because you're building it on the fly.
Yeah, that's a very good point. With the shadows, we needed to use dynamic shadows because we didn't know what was going to come next. And it's also presented a weird challenge. So when you're running through the scenes and you leave one, you would normally say, oh, as soon as it's off the screen, don't worry about it, delete it, right? But if all of a sudden your shadow is in such a way that a building that's off the screen is now casting a shadow here, you go and delete that, all of a sudden the shadow in the scene all of a sudden pops away. And you're like, uh-oh, what did I do? So we needed to make sure that the shadows were never so long in a direction that we couldn't unload that scene for a long period of time. We had a little bit of a buffer zone, but it was kind of one of those things you wouldn't think about, but it was a bit of a challenge.
I think the conversation came up, which was like, we could calculate mathematically the direction of the sun and the height of the building and how long the shadow would be cast. And by the time we even started talking about it, I just increased the padding a little more and solved the problem. So just completely avoid the issue by just giving it a little more gimme space and you're done. Cool. So unless there's any other questions, thank you, guys.
Yes, thank you.